Hello everybody, today we're going to look at how to find a number written as the product of its primes. And really, before we go into the example, I just want to make this clear. Every single number, let's just take 16 for a second, or 7, or 20, they can all be written as a string of prime numbers. So for example, 16 is 2 times 2 times 2 times 2, or in other words, 2 to the power of 4. 7, well, 7's just 7. That is a prime number already. So that is just the one number on its own. That times is on its own to get 7. 20 is going to be 2 times 2 times 5. So that's 2 squared times 5. Every single number, okay, whole number that is, has a unique string of prime numbers that can be multiplied together to form that number. Now, what our job today is to find it for larger numbers than that. So there is a method of doing this, and that is factor trees. So I'm going to use the normal way of doing this to start with, and then I've got my own special method for the further examples that I like. So drawing a factor tree for the number 36, I'm going to write 36, and I'm going to split 36 into any two numbers. Just find two factors. As long as you don't use one, then it's fine. So let's start off. Well, 36 is 6 times 6. So I'm going to split it into there. Now, if we see a prime number, we stop. But neither of these two sixes are prime. We can break them down, therefore, again, because 6 is going to be 2 times 3. 2 times 3. Now, at this stage, we now have all primes. So we stop. As soon as we get to primes, we can't break the number down any further, and we stop. And now we can write this out. 36 is 2 times 3 times 2 times 3. Now, it's good standard practice to write this in index form or exponent form. So that means thinking, well, I've got 2 times 2. Well, that's 2 squared. And I've also got 3 times 3. Well, that's 3 squared. So we should finish our answer by writing them like this. So 36 should be written as 2 squared times 3 squared. Now, I like doing this in a certain way with nice, pretty colors and a nice, more interesting diagram. So I like the hanging basket method. So this is where we take a number. So we're going to use this first example, 102, and I'm going to put it in a basket. There's on my basket. Okay. Now, from there, we're going to carry on doing exactly the same, but I'm going to have my hanging basket having some flowers in it. And in there, well, I know that 102 is 51 and times 2. So I'm going to write 51 there, and I'm going to write 2 there. Now, are any of those primes? Yes, I think a 2 is definitely a prime number. So when I see a prime, I'm going to draw a flower around it. Okay, there we go. Now, 51 is a difficult number. Is that going to be a number that can be split up? Well, yes, because 51 is going to divide exactly by 3. So let's split that 51 up and think about this. Well, it's going to be 3 times 17. So 3 and 17 are there. So let's go through these. Are any of those prime numbers? Yes, that 3 is a prime, so I'm going to draw a nice flower around it. My 17, that's a prime too. It's only got 2 factors, itself and 1. So once I have broken it up into flowers, I have finished. And now I can just write this out with the flowers. So 102 is 2 times 3 times 17. We're kind of done there. All right. Okay, now then, let's go on and do 60. So let's use the flower pot method again. So this time I'm going to write my 60 at the top and my flowers coming down. Well, 60, I guess, is 6 times 10. It wouldn't make a difference if I had picked 2 and 30. I would still end up with the same flowers. Neither of those are primes, so let's split them up. 6 is 3 times 2, and 10 is 5 times 2. And now we can see all of those numbers are prime numbers. So let's put flowers around all of them. Not the best flowers, but you get the idea. And now we just have to write out our flowers. So 60 is equal to, let's put this in index form straight away, 2 squared times 3 times 5. And we're finished. Okay, hopefully that gives you some ideas about how to write a number as the product of its primes.